Hey everyone, and welcome to this explainer. I'm literally so excited you're joining us today because we're going to explore a piece of technology that is radically upgrading our built environments. If you're the kind of person who loves looking at the world around you and figuring out how things tick, you are going to find this absolutely fascinating. We are looking at the death of the static sign and the birth of something entirely new. To really understand why this matters, put yourself in this high stakes scenario. Picture it. You're packed into a massive mega venue. How do you instantly redirect 80,000 cheering fans away from a stadium exit that has just suddenly shut down? If a dangerous crowd bottleneck starts forming, old school painted metal signs are completely useless, right? They simply can't adapt to a real time emergency. They're bolted to the wall, literally saying the exact same thing they said yesterday. So here is our roadmap for today. First, we'll cover the static signage problem. Second, enter AR spatial signage. Third, we'll look at the 5G and IoT ecosystem. Fourth, safety, revenue, and sustainability. And finally, the technical and privacy risks. Okay, let's dive right into section 1, the static signage problem. To really appreciate the solution, we kind of have to grasp how inflexible our current setup is. Think about traditional signage. It's completely static, a total one-size-fits-all approach. It can't cater to an international audience with different language needs, and honestly, it generates a massive amount of plastic and metal waste after big temporary events. Our spatial signage, on the other hand, is completely dynamic. It's multilingual, highly personalized, and it basically treats the stadium architecture as this blank, infinite digital canvas that can adapt in the blink of an eye. Which brings us perfectly to section 2. Enter our spatial signage. We're witnessing a massive shift here, from flat 2D screens to 3D spatial interfaces. Now, this didn't happen overnight. Back in the 90s, static physical signage was the absolute standard. Then, in the 2010s, we started experimenting with augmented reality, but honestly, it was pretty inefficient. It relied on marker-based tracking, meaning you had to physically walk up and scan a QR code printed on a wall, which is obviously useless for moving a massive crowd. But now in the 2020s, we finally evolved. We now have markerless spatial tracking driven by incredibly lightweight machine learning models that just continuously analyze the environment around you. The real magic behind all of this comes down to one specific acronym, SLAM. That stands for Simultaneous Localization and Mapping. These algorithms can instantly recognize the physical geometry of a space. They look at structural pillars, stairs, or concrete corridors and turn them into what we call spatial anchors. So the digital directional arrows or the personalized ads are literally painted onto these spatial anchors on your screen, maintaining your exact point of view as you walk down the hall. This is honestly a massive game changer. Harvard University actually calls this an architectural recontextualization. We aren't just staring at a flat 2D map on our phones anymore. We're fundamentally changing the context of the architectural space itself, creating a changing digital surface without permanently clogging up the physical building. But hey, this amazing spatial signage doesn't just function in a vacuum. Let's move to section 3, the 5G and IoT ecosystem. Just think about this number for a second, 50,000. If you try putting 50,000 people in a stadium on a standard 4G network and ask their phones to simultaneously render high-fidelity 3D spatial graphics, the system would instantly become overwhelmed and crash. The bandwidth just isn't there. So let's see how this builds into a brilliant real-time loop that keeps crowds moving safely. Step 1, Internet of Things, or IoT. Turnstile sensors detect that a certain area of the stadium is full, recognizing a bottleneck. Step 2, 5G edge computing instantly processes that heavy spatial data locally, right there at the venue. Step 3, the system automatically adjusts and the AR directions dynamically change on everyone's screens to divert foot traffic safely away from the danger zone. That 5G edge computing piece, it is absolutely crucial. It processes the data physically closer to the user. Without this low latency local computing power, the digital graphics would lag, or they'd start literally drifting off the walls as you walk, completely ruining the illusion. It also means this whole setup carries a risk, right? A local network outage would cause the dynamic wayfinding system to collapse entirely, meaning venues still need really robust physical fallback procedures. So why are major event organizers rushing to adopt this right now? That brings us to section 4, safety, revenue, and sustainability. It basically boils down to three massive drivers. First, public safety. The ability to reroute foot traffic instantly drastically cuts down the risk of crowd crushes. Second, economics. This tech turns blank walls into limitless real estate. Think about it. Two fans looking at the exact same blank concrete wall can see totally different hyper-localized ads based on their own personal preferences and native language. And third, the environment. By shifting to a digital overlay, venues can drastically decrease all that massive plastic and metal waste generated by temporary event signs. And actually, this plays right into the United Nations Sustainable Development Goal 11, Sustainable Cities and Communities. By utilizing personalized wayfinding and immersive public art, we can take these sterile concrete environments and turn them into inclusive, welcoming, and above all, safe and resilient spaces for everyone. Of course, deploying this on a massive scale introduces some very real plot twists. Let's look at Section 5, Technical and Privacy Risks. We're essentially looking at dual threats when it comes to adopting this disruptive tech. On the technical side, we have something called dynamic occlusion, which we'll break down in a second, and developers are furiously working on advanced machine learning models to fix it. But on the ethical side, markerless tracking requires constant camera scanning. Naturally, that raises massive privacy concerns, making robust, absolutely fail-safe data anonymization practices mandatory. Let's zoom in on that technical flaw for a second. Dynamic occlusion. You know, human bodies are actually the system's Achilles heel. When thousands of fans suddenly stand up and cheer, they physically block the stadium walls. Because the SLAM algorithms depend on seeing the geometry of the building, those stairs and pillars we talked about, blocking them causes the whole system to get confused and lose its anchors. The AI literally has to be trained to ignore us, to discard moving human figures, and only pay attention to the static architecture. But honestly, the far greater hurdle might be the privacy issue. To construct this amazing 3D space, the user's camera has to constantly scan the public area. If data anonymization is inadequate or even just poorly designed, this technology could be recording real-time video of thousands of unaware people. It could easily transform a helpful public safety tool into a highly invasive mass surveillance system. Which leaves us with this final, incredibly provocative thought. As our built environments get radically upgraded, are we willing to trade our visual privacy for safer, smarter, and more sustainable cities? It's a really complex balancing act between amazing architectural recontextualization and the protection of our personal data. Thanks for watching this explainer. See you soon with another awesome video.